Welcome everybody. My name is Brecht. I'll be giving a talk about my project rinohtype. It's a project I've been working on since 2008. I was doing a PhD back then. I was using LaTeX and I was kind of getting fed up with it because of the difficult error messages and difficulty to create a custom style. So these were the reasons I started working on rinohtype. Now finally, after all these years, it's in a kind of beta stage, so it's more or less ready for general use. So what is it? If you're not familiar with, if you're familiar with LaTeX, you will know how it works. It's a batch document processor. As an input, it takes a structured document. This can be restructured text or a markdown format. Besides these lightweight markup formats, it also accepts, or there's a very simple front end for docbook files, and there's also a commercial front end for data files, which is an XML format that is used by technical writers. Of course, besides the text stored in the structured document, we can also provide images. Rinohtype accepts PDF, PNG, and JPEG images. If you want to use other bitmaps, you can do so if below is installed. To style the output, rinohtype depends on style definition in the form of a style sheet and a document template. These are both in plain text files in INI format. And besides these style definitions, we also require fonts. And rinohtype supports the most common font formats such as OpenType, TrueType, and the PostScript Type 1 format. So combining these inputs, rinohtype will produce an output that is a PDF document. An example of its usage, rinohtype comes with a command line tool called Rhino. We can pass a restructured text document or the file name of a restructured text document to it, and Rhino will render it to a PDF file and tell you about it like this. It also accepts common mark, so common mark markdown files. You can see that that Rhino also accepts some options. We'll go over them later. For example, this one renders a document to an A5 paper format. It also presents the progress using a progress bar, so you can see how long it will take to render the document. Besides the command line tool, there is also a Sphinx Build. This is basically a drop-in replacement for the LaTeX builder, so you do not require to have a large LaTeX installation to produce PDFs from Sphinx anymore. You can use it like this, using the Sphinx Build command. You just pass the Rhino option, Rhino to the builder option of Sphinx Build, along with the source directory and the output directory. I will also give an example of this further on. As for installation, rinohtype works on Python 3 only, Python 3.3 and up to be precise. It's written in pure Python, so there's no compilation required, and it depends on just a couple of external packages. So there's packages for common mark or markdown support for restructured text that is handled by docutils, and then there's pure PNG to parse PNG files. And besides that, rinohtype also packages fonts separately, so these are also installed when you install rinohtype. For the next release, I've planned to also provide standalone applications, so if you don't have Python installed, you can just download a Windows installer or macOS application bundle, and that includes Python along with rinohtype. So I want to give a small demo. This will be difficult. So in this folder we have an example restructured text file. So with a document title, section, another section, and then a subsection, a paragraph here with a link in it, a small table, another paragraph in the second section, and some nested lists. So we can just call Rhino, passing it the file name. And you can see it renders, has to render the document twice, and this is to make sure that page references are handled correctly. You know, with LaTeX, if you're familiar with LaTeX, you know you have to run it a couple of times. rinohtype handles this transparently, and you mostly need 2 runs for a single document. If we run it again, it will only need a single pass because it writes a cache file storing reference information. Then for the Sphinx Builder, I've, as an example, taken a relatively small Sphinx project from the simple JSON project. To make this build with rinohtype, we have to make one small adjustment, and that's to add the Sphinx Builder module location to the list of extensions in convil.py. After this, we can run Sphinx Build like this, so passing it the Rhino as the builder option, the source directory, which is the current directory in this case, and an output directory. And then you get the standard Sphinx outputs along with rinohtype's progress indicator, so this takes a little bit longer because it's a larger document. And again, there's a second pass. And then I'll show, perhaps show the output of the first example. So this Rhino by default uses the article template, which consists of a title page. So we have document title here that was specified in this restructured text document, along with the date. Then we have a table of contents, which is hyperlinked to the pages and also lists the pages as you'd expect. And rinohtype also generates bookmarks in PDF, so we can jump to each section using that. So this is the content, actual content of the document. You can see the 2 sections and the table. Then the output of the Sphinx Builder. So this uses the book template by default, which can be configured. So it's a title page, a larger table of contents, and then the actual content is a preface. You can also see the syntax highlighting for code blocks. And this is the first chapter, so you can see that chapters start on new pages. And you might recognize the style of the document. It's modeled after the LaTeX output produced by Sphinx. So that's a default style sheet shipped with rinohtype. Special in the book template is that it also generates an index. This is not limited to documents generated by Sphinx. It's also possible for plain restructured text documents. So it's generated by rinohtype itself. So let's go back to the presentation. So this is a summary of what I've shown. For the Sphinx Builder, it basically uses the LaTeX document definition in conv.py. So if you have LaTeX output configured, rinohtype will interpret this configuration. You only have to add it to the list of extensions. So suppose we want to change the style of the output. First, we need to know how rinohtype handles this. In fact, it's very similar to CSS, where we select the elements on the page using selectors, and this is performed in the document tree. So the front end, it creates a document tree, which is then transformed to internal representation in rinohtype to another document tree. And this one, for this sample document, is displayed on the right. We have the 2 sections, each with a unique ID. a subsection, and you have the heading of the section, paragraph, table over here, and the list over here. So once we have this, we can start selecting elements. Oh, let me first say that paragraphs are also included in this document tree, and they also consist of a tree to represent nested styling. So this paragraph above with nested styling is represented in this tree. So we have, for example, the simple text without styling, and then there's this whole part is emphasized. That's this one, and part of that is then strongly emphasized, and so on. So this basically completes the tree shown above in the previous slide. So we can match elements based on their context, just like in CSS. Each element in this tree is called a flowable, which is flowed onto a page, and it can adapt to the width of the page or center itself inside the available width. Also, each element in this tree is a Python object, and so this is a class name. So these selectors are basically Python source code. Using operator overloading, we can use this to construct selectors. So for example, this one represents a table cell, or represents a paragraph that's a direct child of a table cell by using the / notation. So it selects in this tree this paragraph, for example. We can use the ellipsis that's provided by Python to match multiple levels of elements, and this selects then all paragraphs that are part of a list, so as well as this list item in the enumerated list. It also matches the paragraph in the bulleted list. We can also match elements based on their style. Style is similar to HTML's ID or class attributes. For example, enumerated lists, as you can see, they are the same object. Enumerated and bulleted lists are the same flowable, but their style is different. So this is enumerated and this is bulleted, and that's basically the enumerated is provided by styling it as an enumerated list. And it's selected like this using this class method called like, and then passing the style name. We can also match arbitrary attributes, such as the level. The section has a level attribute specified that specifies its level in the hierarchy. So this is a level 2 section, so this is a level 1 section, as well as this one, so it's not selected, but this one is subsection is a level 2 section, and we select the heading below it, so it matches this element. We can do some more complex things like this, but I will not go into detail about this. Different from CSS is that rinohtype provides an extra level of abstraction. So instead of specifying selectors in a style sheet, we first map the selectors to style names. This has two advantages. They provide a descriptive name. And second, these matchers that collect all these selectors and map them to style names can be reused by multiple style sheets. So this saves some work. We can also reuse style names in new selector definitions. So line block over here is defined like this, and if we combine them, we can map that to a nested line block. There's some more examples given, but they're pretty straightforward. Then onto the style sheet. As I said, it's a basic text file in INI format. So a style sheet starts with the style sheet section, and we can give it a name. It also supports variables. So, for example, we can define a variable sans typeface to specify which font to use for all sans serif typefaces in the document. So if we use this variable in style definitions later on, we only need to change this one. Same for color blue, which can later be changed easily. Then we define a default paragraph style. So except for these two sections, all of the other sections, they should map to style names that are defined in a matcher. Except for this one, it is not specified in the matcher, and that's why we have to specify that it's a paragraph style. Why? Because this is used as a base for other styles. So we can define some font properties, some settings regarding to typesetting, text alignment, how to align the text horizontally. Then we have the body style. This is a style for body paragraphs, so most of the paragraphs in your document. It has the base style, default as the base style, so it basically inherits all of these properties and adds the space above property. And then we also have an inline text style for emphasized text, and this sets the font's length to italic. We also support inheritance in style sheets, so mostly you will use a style sheet that is shipped with rinohtype or provided separately. You can inherit from this simply by specifying the base. So Sphinx is a style sheet that is included with rinohtype, and you can just specify it by name. You can also specify others by file name, for example. We can override variables. So, for example, we replace all sans typefaces with droid sans in this style sheet. And we also override emphasized text. Note that this inherits all properties of the emphasized text or emphasis style of the base style sheet, and additionally sets the font color. So text will be italic and receive a color. If you don't want to inherit the properties of the base style sheet style, you can set base to default style as indicated here. So this will only change the font color and not the font weight as was done in the base style sheet, for example. How much time is left? 10 minutes, okay. So because this is a little bit slower with one hand. So suppose we want to change some of the properties of the restructured text document I've shown before. Now, how do we find out which style definitions we have to change? For this, rinohtype, I need to change back. Every time rinohtype renders a document, it also generates a style log. And this is basically a representation of the document as it is rendered. For each page, it will list the tree of the elements that have been rendered to the page. So let's go to page 3 where the actual content is. And there we can find the first section, and we can see that this maps to the chapter style. For the section heading, it maps to the heading level 1 style. So we can start and change this in the style sheet. In case heading level 1 was not specified in the style sheet, it would move on. Put an X here, and it would move on to the next style in the list. So we can do this for the example document. So here we specified some name, description, and which base style sheet to use. We also override a variable which changes the font, and finally we change the heading level style. So it also inherits from the base style, but we change some properties such as font size, font weight, font color, and also change the format of the number preceding the section title. And similar for level 2, we make similar changes. So the result of this, to make it use the custom style sheet, we can specify it like this. So -- style sheet, specify the file name. And then this is the original document, and this is with the changed style sheet. So you can see that section titles have been have received a different color. The numbering is changed to using Roman numerals, and also this title has changed and using A, B, C for the section titles, section numbers. And you can also see that the font has changed because we set the variable not only in the body paragraphs but also in the table. Finally, we can also customize the look of the output document by using document templates. These determine which parts are part of a document. So typically there's a title page, front matter with table of contents and possibly other things. Then the actual contents of the document, and finally back matter with an index. So this is defined by the template. And for each document part, there's also a page template provided, and this can be configured. So for example, margins can be set, the number of columns, the spacing between columns, and which text to place in the header and the footer fields, for example. And besides the configuration of the page templates, you can also configure certain aspects of the document parts. So here's an example. So we configure the article template, which is part of the rinohtype distribution. We specify which parts to include in the output. So here it omits the front and back matter, so only leaves the title and the contents parts. You can also specify which style sheet to use. You can specify which language to use for typical titles, such as table of contents or the index. And we can also, for the article template, as a special option which allows you to select where to display the abstract on the title page or later in the document. We can also override the titles for sections, so the language already sets these for each language, but you can still override them like this. So for the table of contents, you can manually give a string. Again, you can work with variables. The paper size variable is used in the page templates, so this will change the page all over the document. And this corresponds to the title part. And so you can set the page number format using lowercase Roman numerals in this case, and at which page to end the part. So this makes sure that the next part starts on a right-hand page. And for the title page template, you can set the margins. For example, top margin is changed here, and you can even set a background using this PDF image, and we can set the scale option to fill or fit the page, for example. So this is an example of style for the rinohtype manual I've been working on, and it shows what is possible. So using margins and indentation in a smart way, you can obtain this kind of result. It also changes the link color, etc. And this is using a background for the title to make it a little bit more nice. And this is then a page spread with a left page and a right page. So it changes the footers separately for the left and the right hand pages to obtain this result. Now, all of these things like style sheets and document templates, they are handled similarly by rinohtype. They are called resources, and they can be retrieved by name, so by entry point. So these can be provided in separate packages on PyPI and then used in documents by just referring to them by name. You can find out which of them are installed by using the appropriate list options. Also, the front ends are handled in this way. So in the future, I hope to enable to automatically install fonts, for example, from PyPI when it's being used by documents, so you don't have to manually install it when you retrieve a document and render it. So that's it. Some more references and contact information. Do we have still time for questions? A couple of questions. No, that is not supported at this moment. No. It's the PDF backend is as simple as possible at this moment to make this possible.
Is there a simple way to import data packages to use the format?
No. But there is that would be a fun project perhaps. There's a LaTeX parser for Python, only 2.7. You could use it to write the front end for rinohtype. And I think it even like evaluates tech code, so perhaps it's pretty powerful. Yes?
Can I select the alignment of images or the style sheet or something?
Sorry, can you repeat the question?
Can I set the alignment of an image via the style sheet or template?
Yes, you can set the alignment of images using the style sheet. Yes? It does handle Unicode, but it's not been properly tested with other scripts yet. But that's why I wrote it in Python 3, so that internally it's all Unicode, so that.
The PDF generation has been over.
Yeah.
Right to left.
Yeah. It doesn't. Yeah, right to left is not yet supported, but Unicode it should handle. Yes. It does, depending on if the custom directive expands to known directive. You don't have to change anything in rinohtype, but you can also, for example, create a specific flowable that renders your custom directive. Yes?
How difficult is it to implement another front-end? I'm thinking, for example, textile.
It should not be too difficult. It starts from document tree, in which each node has a name, and this is mapped to a Python class. So in this class, you implement the mapping to the internal representation.
Can you render multiple files into one here?
So with Sphinx, Sphinx kind of handles this for restructured text. But for other formats, like the basic restructured text front end, it's not possible to pass it to two documents, and it will not concatenate it. That's not supported now. Okay, that's it, I think. Thank you.